Hello, welcome back to another math video. Today we're going to take a look at trigonometry. And before we have looked at sine law and cosine law, those still built on the concept of triangles, very much extension of Math 10. However, we would like to look beyond just triangles. Okay, I know it's called trigonometry, but trigonometry is the triangle, just a foundation for studying of angles in general. Okay, angles in general. So remember, in a triangle, okay, the three angles must add up to 180 degrees. So the three angles better also be less than 180, right? So in one triangle, all three of the angles must be less than 180. So it can be acute, it can be a right angle, or obtuse. But those are far from the only angles that exists, right? Here are some examples of angles. Okay, here are some examples of angles. First, you have 35 degrees, an acute angle, looks like that, right? This is acute. 145 degrees, probably looks something more like that, right? 145. This is obtuse. Some of you may have learned the other angles, 215 degrees, okay, way bigger than 180, right? Probably looks something more like that, right? 215, right? I'm starting drawing some arrows there, okay? You will know why I start drawing arrows. And of course, 325 degrees, that's almost a full circle, right? Almost go all the way around, right? 325 degrees. Those big angles right here, they're called reflex angles, right? They're like the opposite of the acute angles or the obtuse angles, right? So they are called reflex or reflex angles. The name doesn't matter too much though. Is these numbers or even angles like 1000 degrees, right? All these angles, okay, all these angles are valid angles, but we do not have the tools or methodology to do trigonometry or study or work with them in general. Okay, in general, there's no standard that can help us deal with them. So before we begin doing trig with this weird and big gigantic angles, also don't forget you can do negative angles too, right? Negative 140 degrees, right? Okay, before we can deal with these strange angles, we need to develop a standard for writing down angles, recording angles, and from there extend it to higher degrees. Okay, so that's what we're talking about angles in standard precision. You'll see, right, there is a box that describes it, but I think it's best we draw it from scratch. Okay, draw it from scratch. So consider the following angles. Okay, we have let's see, we have an obtuse one. Let's say this is 145 degrees. Okay, then we have a acute one, which we're going to use. Let's use different color, actually. Let's use green for the acute one. Let's call this 35 degrees. Okay, and let's do a reflex one, which we'll deal with last. Okay, reflex one. Let's say this one is 215 degrees. 215. So like that, 215 degrees. Okay, how can we compare these three angles? Okay, I told you the numbers, of course, but how can we do trig with these how can we even standardize them? Well, what are the common properties of all angles? First, they all have a pointy end. Pointy, 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 pointy. Okay, to compare these angles, we better have a standard where all the pointy ends meet up. Okay, we call that the origin. So all the pointy, okay, this is a standard position. Okay, oh, I should use different color than all of them. Let's use purple. Okay, so all the pointy ends gonna meet together. So all the angles in standard position better have the pointy ends at one spot. We call that the origin. So this is a standard position. So this is the origin. Okay, all the angles vertex is at the origin. Also, the angle have two arms. If the arms just float around in space, you cannot compare how wide those arms are. We need at least one of the arms match up with everybody, and the other arm, we compare how the other arm moves. Okay, the further away the other arm moved from the reference arm, okay, we say it's a bigger angle. We can then compare them. Okay, the reference arm we call the initial arm. Okay, the initial arm. So let's say the initial arm is always going horizontal to the right. Okay, this is the initial arm. We call this. So all the angles are going to start here, and the other arm's going to go here, angle 1, or here, angle 2, etc. Okay, so all the initial arm's going to match up, and the other arm moves. Well, maybe it's a good idea to pick a few reference arms. Let's make it, let's say, like a lumber line, like so. Okay, and then we can, of course, do a vertical angle as well. Oh, let's draw it actually. I'll try to draw it straight, but my hand's going to shake. That's okay. Wait a second. This look familiar. This is just the Cartesian plane. Cartesian plane. And the initial arm is just the, be careful, it's just this part, the half of the x-axis. This is the x-axis, but the initial arm is just the positive x-axis. Of course, we could develop a brand new system to compare angles, but Cartesian planes, as you will see right away, is a perfectly fine way to compare various angles. So why not just use it? With the origin of the Cartesian plane being where all the vertex of the angle is. So this is going to be the vertex of the angles. Vertex of angles of the angle, right? And the initial arm is always the positive x-axis. Okay, positive x-axis. So what would an angle look like in standard position then on the Cartesian plane? Well, let's do the first one by example. The green, let's start with our most common one. One we'll work with the most. 35 degrees in the acute angle. Well, 35 degree have two arms. We have to pick an initial arm. Doesn't matter which one it is. Okay, as long as the other one move, as long as the vertex is here. So the vertex is going to be here. The vertex is at the origin. One of the arm is always going to be on a positive x-axis. That's one arm. And the second arm is going to be 35 degrees away from it, from this other angle. But you might say, which direction do we make? Convention is to always go counterclockwise. Counterclockwise is positive. I'll say CCW is positive. Okay, so if we move the other arm counterclockwise by 35 degrees, okay, 35 degrees, then this is 35 degrees in standard position. Okay, let's call it A. This is A in standard position. A is equal to positive 35 degrees. Okay, so counterclockwise is positive. Of course, we can do something similar if we want to draw a negative angle, which we don't, but if we want to draw a negative angle, I'll do it in dot, means it's not actually part of the same picture. Okay, we can draw a negative angle. This is 35 degrees as well. You could say that. Then this angle, let's call it A dot. The A dot is actually negative 35 degrees. Okay. How do you indicate direction? You might notice when I draw the angle, I actually draw the mark for the angle and an arrow. Okay, for Math 20, we'll be dealing most of the time with positive angles, but you should know what negative angles look like. Okay, negative angles look like. Be careful. Negative angles can still be acute, like this one. Okay, like this one. It's a negative acute angle. Now I'm going to erase negative one because I'm going to draw more angles, and if I draw a negative one on there in addition to the two other ones, it'll just become really confusing. But just remember, positive direction and negative direction is just counterclockwise and clockwise, and you just make sure you're marking which your arrow indicates so. Let's draw our second one, 145 degrees. Let's call this angle B. Oh, I forgot to change color. Angle B, around 45 degrees. The origin is still here. Origin is still here. Initial arm is still here. I'm going to draw a little shorter. Okay. In fact, you do not actually need to draw the arrow for the arm, but to recognize it is a ray may be helpful. Okay. I'm not going to be too picky on that for angle drawing. Okay. For graphs, it's a different problem. Okay. If you're drawing a graph or a function, that's a little different. But for angle, now our initial arm is here. Our other angle, remember, it's positive 145 degrees. So I'm going to need to draw my other arm positive 145 degrees. How far away is 145 degrees? Let's think about this. How far away is this vertical pink line on our initial arm? Oh, initial arm just the x-axis. Well, positive part. The vertical one is the y-axis, right? This is the y-axis. Which means this angle here is 90 degrees, right? Because two axes are perpendicular to each other. It's 90 degrees. Okay, you can say it's positive 90 degrees even. Okay, but without direction, that measurement is 90 degrees. So if that is 90, 145 is bigger than 90, so my arm better go past 90 degrees. In fact, how much past? Well, if this is 90 degrees here, then 90 plus 30, 55 will give us 140, 145. Let me quickly change that. So if this distance, okay, if this distance dot is 55 degrees, then the whole angle will be 90 plus 55, which is equal to 145 degrees, right? That's a little bit exaggerated, so I'm going to redraw this. Okay, so this angle here, let me erase the 55 first. Write a really small 55. For this angle here is 55. Notice no direction. This is just for us to reference. The actual angle, you do not need to label that one, but the actual angle you should label is the entire obtuse angle, which is, once again, 90 plus 140, 55, 90 plus 55 degrees, which is positive 145 degrees. And you can write B right there. You can write B right there. So you have the green, positive 35 degrees, and now you have B, positive 145 degrees. Okay, drawn in this case, drawn in black. Okay, drawn in black. Okay. Okay. Do you have a feeling now how to draw angles in standard position? This picture is getting a little busy, but up to you. You can draw a separate grid, or just as practice, just as a challenge. Okay, can you draw 215 on the same grid here? Like I said, drawing on the different grid maybe make it easier to see, but just for fun, can you draw 215 degrees on your own? Pause the video, okay, draw it, and we'll come back, see if we can draw, oh, by the way, positive 215 degrees. Of course, guess you for fun, you can draw the negative one and see what it looks like. Okay, this is angle C. This is angle C. All right, hopefully you pause the video and actually try to draw this yourself. All right, the vertex of the angle is always at the origin. Okay, one of the arm, always start the initial, always the positive x-axis. Now, 215 degrees is very big. It's reflexive. It is in 215 is in fact bigger than 180, and 180 is a straight line. Wait a second, what does a straight line look like? Remember, part of this is one of the angle is this. Wait, straight line wouldn't just look like that. That's right. This angle here, if we draw it, is 180. It's 180. Okay, so I'm gonna do the tiny dot thing again. That's 180 degrees. Okay, that's 180 degrees. So you can think of this line is 180 degrees. How much do we need to add to get 215? Okay, 215, of course, is 180 plus 35. So remember, plus positive counterclockwise. So we need to go more this way by 35 degrees, right? Oh, I should have used dotted version. Dot, 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 dot. So here we go. So of course, this tiny amount is 35 degrees. So remember, I wrote this down for reference, okay? But the actual angle is a big one all the way around. Don't forget the arrow to indicate the direction, positive direction. This is C equal to what? 180 plus 35, 215 degrees. I didn't mention it's hard to see, so I drew a smaller version on the side. So 215 degrees actually looks like this, the blue initial arm to the other side. Boom. Positive 215 degrees. I do recommend writing down positive, but positive you do not need to write down positive, just like before. But during practice, writing down positive may help. Writing down positive may help. All right, let's look. I'll leave a challenge for you, which you will not draw on here. Can you draw? Well, I think what's the last one we had for an example there? 325. Let's draw 325 degrees. Okay. I'm not even gonna draw the original angle, floating angle, okay, non-standard angle for you. Just try to draw it completely from blank. I think I already gave you the strategy how you might draw it. You will need to use either the bottom side or the original side for reference, okay? We're gonna use the blue one. This is probably the newest one as an example of to explain the parts and terminologies we use to study angles to identify angle in standard position. And in our next video, we'll look at how we can actually analyze it. So let's draw the grid again. Oh, maybe I should make it thinner. A bit longer. All right, and I'm going to draw the 215 degrees here. Vertex, boom, like that. Okay, just to highlight the arms, I'm going to draw the arrows on there, just to make sure the arms of the angle is clear. And of course, I will draw the labeling. Okay, this is positive 215 degrees. Okay, positive 215 degrees. All right, this you already know, it's called the vertex or origin. So this is vertex, or you can call it the origin. Okay. This arm here, we already gave the name, it's called the initial arm. Direction, of course, counterclockwise is positive, clockwise is negative, and the initial arm goes all the way. This is just, you can call, I don't have a name for this. I just call it an marker or indicator, an angle marker. Okay, it goes from initial, start initial, ends in the second arm. It ends here, so we call this the end, the terminal arm. This marker in between indicates the angle. Okay, the angle is on that side. Because since we talk about direction, if you mark this side, even though it looks like the same angle, it's actually a very different angle. We'll talk about that. They may look the same, the arms may look the same, but they're actually different angles. Okay, actually be careful. So this side, where you do the marking, is the actual angle. So angle in standard position have four parts if you count the vertex. 4 parts. The vertex at the origin, same name, so hopefully you're easy to remember where it is. The initial arm is always the positive x-axis, and the terminal arm is the one arm that moves away. Okay, terminal arms, it moves away. The direction you mark, it move away. The direction you indicate, it moves, like this arrow, is the actual angle. Okay, is the actual angle. So there are 4 parts to angle in standard position. Okay, 4 parts to standard position. Okay, so that's what I was leading up to, and that's what this box is talking about. Okay, angle standard position always starts. Let's see if you can fill this out without me telling you. Okay, since I just defined. Okay, that's right. Well, hopefully you actually try to fill out yourself. The first one, angle always start on the initial arm. Which is also the positive x-axis. I'm just going to write pause. Oh, you know what? I can just use symbols. Positive x-axis, not x-intercept, different thing. I know it has to have x in it. It's positive x-axis. So this. All right, let's go backwards. All right. The center of position of the vertex at the origin. They're actually interchangeable. The vertex is right here. Okay, positive angles is started position, always rotate counterclockwise. So that's why it's important for you to label it. Always rotate counter. I'll write the whole word out for the only time. Okay, only time. Counterclockwise. So like that. That's the angle. Right, that's the angle. And finally, the angle ends at the end. The ending arm, the terminal arm. So ends here. Okay, ends there. All right, so this is the standard position and the standards for we're going to analyze angles. Okay, from now on, individual angles outside of triangles. Okay, outside of triangles, because triangles can only deal with acute and obtuse. Okay, you cannot deal with bigger angles. All right, so here's a quick exercise. I will not tell you, okay, which of these angles are in standard position, which ones are not. Be careful, they're not all in standard position. That's why I asked. Okay, that's why I asked. And think about why. Another exercise here would be for you to take a look at this graph. We'll actually start the next video with this one, just as a quick recap. But for now, I'm not going to answer it. Fill this out. Don't forget quadrant 1. Label the quadrants 1, 2, 3, 4. This is review. Okay, this we just talked about. Okay, label the angle zeta in standard position. Don't forget counterclockwise from initial to terminal. Counterclockwise. Okay, this is the one I would like you to focus on. Can you label / draw 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, those angles are quite special. Okay, those angles are quite special, and those will provide really good reference for us to study and comparing different angles. Okay, so make sure you label this on this one. And next video, we'll take a look at more at standard position and are some rules before we can look at trigonometry. And with that, thank you for watching. Tune in next time for more angle tricks and tips.